Hello everyone, welcome to ChemUp Academy, where chemistry is simplified and success is amplified. So today we shall be beginning about our mains class. So this is gonna be your first lecture, and the topic for today shall be your analytical chemistry. Analytical chemistry, you can write mains topic you may involve as errors and quantitative analysis. Alright. Errors and its quantitative analysis, and we can place it as lecture number 1. So from today we can again keep a track for this thing. Okay, so what basically is analytical chemistry? It is something like in which you can just determine certain things, like if you are having an analyte, if you are having certain sort of analytes or a sample, and you need to determine certain thing, like you want to determine the concentration of anything, like you are taking a blood sample, and in that blood sample you need to determine how much chlorine is content is present, or we are taking a sample of water in which alcohol is mixed. Now we want to determine the amount or the concentration of alcohol present in that particular thing. So this is basically your practical subject and most important subject that you're going to be focusing on, or that will help you to yield good marks in your I would say the examination, and of course the interview for UPSC. So it would be better if you pay attention. So this topic is actually your mathematical topic. And coming on to the analytical chemistry, analytical chemistry is analytical chemistry it is again a branch of chemistry, a branch of science which deals with finding the concentration, which deals with determining certain amounts or whatever we want to for the component known as analyte. So therefore, we come across a term known as analyte. Analyte in yesterday's class also we did while we were doing titration. So in that also we did. Analyte is what? Analyte is something whose concentration is not known. Whose concentration is not known, or it has to be determined. It has to be determined. This is all we all know about the analyte. It could be your sample. You can just call it in a simple or lame term as your sample. Now, another thing that comes from analytical chemistry is the matrix. The two things comes. First is the analyte, that means the sample, and second comes the matrix, means the components, all the components that make up the sample. That means all the components that are making up your sample is known as your matrix. So analytical chemistry basically deals with these two things. That means we can determine certain objects, we can determine the concentration, we can follow it up for more even processes, and in order to determine the analytes and also the matrices. So this is whole about your analytical chemistry. Nothing. Okay, one more thing is that analytical chemistry finds its application where? It finds its application in your geology, in your biology, in your organics, of course, your chemistry, your quantum, your physics, and has so many other various applications. So this was just a brief about your analytical chemistry. Coming on to our first topic regarding this analytical chemistry. But before actually moving on to the topic, there is certain thing that means we say that analyze versus determine. These two terms are usually misinterpreted by most of the students. What happens is there are certain things which we say that you need to analyze it, and there are certain things which we say that you need to determine it. Supposedly, taking an example of, let's say, example of blood as well, blood only, which says that you need to just determine the content of chloride ions present in your blood sample. So what we will do is that we can say that we analyze the blood sample to determine the chloride ion content present in analyte. Analyte is now known term for you. So what are we doing? What we are doing is that we are analyzing the sample. We will always analyze the sample so as to determine the chloride ion content that is present in it. So we always analyze the analyte in order to determine the concentration. So this is how we're going to use these two different terms. You can mark this as important. Okay, coming on to the topic, the actual topic from where this particular thing starts, errors and analysis. So before actually proceeding to errors, we should be aware of the term that is significant figures. What basically are significant figures? How can we just round off our significant figures? See, whenever you would be presenting your answer, there is a scientific notation in which you need to present yourself. Say, you have been given a molarity, and respective to that molarity you just need to present yourself how the things will come on after solving a particular question. So that particular answer needs to be presented with respect to the significant figures in terms of scientific notation that has already been provided to you in the question. So you will be able to reach the answer nicely. But UPSC mains demands that since it is a descriptive type of questions, and also every year 5 to 10 to 15 to 20 marks question is always seen from this particular topic, so you can mark it important. And it is not a hodgepodge thing that you will not be able to get it. It's a very simple thing. You just need to pay attention. So significant figures, writing the table as significant figures, we say that significant figures. Where will they be required by you? You would be requiring them when you would be solving the numericals related to errors in your analytical chemistry paper. So significant figures are the minimum figures, are the minimum numbers that could be used to present an answer, to present an answer for determined analyte in scientific notation. That stands. This is just the general definition from the lame terms only. That means scientific figures that you have studied in your previous classes also, like if you are having a maths background, of course we all have maths background from class 1 up till class 10, and in those levels only we had learnt about the scientific figures. So it is just a brief regarding that. So scientific figures could be like, say, let's take an example. Supposedly I have 3 4 2 0 1. So how many figures? Let us just count. 1, 2, 3, 4, 5. It says that it has 5 significant figures. Let's take another example. 4.201. It will give me 1, 2, 3, 4. 4 significant figures it has. So just counting things like that and getting onto the significant figures is what we have to do. But it's not that easy. The thing that is determined or that you can see on the page, it's not actually that easy. What if I give you something like 4.20, 10 to the power 5, then ask you how many significant figures are there? You would be calculating like 1, 2, and 3. It says 3 significant figures it has. Now, what if I ask you another question saying that how many significant figures it has? So, some would say that it has 1, 2, 3, 4, 5. No, but it only has 2 significant figures. So, the basic problem is that obviously the numbers that are coming, that we need to count directly. Numbers, non-zero numbers are to be counted directly for significant figures. Let's write the rules. Rules say non-zero numbers will contribute to significant figures. This is our rule number 1. As we have seen in the previous case also, that means non-zero terms. This is non-zero term, non-zero term, non-zero term, but here this is a zero term and here it is non-zero term. Still we are including this zero term. So what is this confusion between the zero, where to include it and where not to include it, where not to include it and where to include it? So for zero, let's say that where is okay, for 0 what we can say is that in case of 0, in case of 0, first case it says that if it is present between two non-zero terms, it is included. If it is there between non-two zero terms, it is included. Like like this, it is present between two non-zero terms. This is a non-zero term, this is a non-zero term, and 0 is between these two. Therefore, we will include it. Here, we can say 0 is included. Now, what if 0 is not present there? If 0 is not present there, then we can say that second point comes, which says that if 0 is after the decimal point, or I would say right to the decimal point, it is included. If it is right to the decimal point, it is included. Like in our case, we have it was right to the decimal point. Here, it was right to the decimal point. Therefore, we have included it. And here, the 0 was left to the decimal point. Therefore, it was not included. So, two rules we have understood regarding 0. And for non-zero, it is simple. For 0, we have two rules. If it is present between two non-zero terms, it has to be included. Another one says that if 0 is after the decimal point, it has to be included. Now, coming on to the third rule. Third rule can be of your addition and subtraction. What is meant by addition and subtraction? Say we have point terms, and when we have point terms, we just need to focus on how to add and how to subtract the significant figures. Let's take an example. Say we need to add 2.1, 5.23, 4.006, and now we need to add these terms. Examples we are taking. So on adding these two terms, before actually adding, let me just give you a hint for a certain things. Whenever we will add or subtract, answer should always be according to key number. And what is this key number? This key number means number having least significant figures. This means that key number is one which has least significant figures. So let's just calculate. Here we have 6, here we have 3, 3.11. Now this is our calculated answer. But answer that we shall be representing is according to the key number, and this is our key number. Therefore, how many places we have? Only one decimal place. Let's just round off up till here. On rounding off, what we need to observe is that what is after 3? If it is less than 5, here we are following rounding off. If it is less than 5, the number stays as it is. If it is more than 5, the number usually increases by one digit. So we have 11.33, therefore it becomes as 11.3 as an answer. In most accepted scientific notation, this is how we perform the addition and subtraction. What if we try to perform multiplication and division? Let's see for multiplication. Or division. For multiplication and division, again, answer should be according to the key number. Your answer should be according to the key number. Let's just perform 0.6, 1.2 into, let's take 0.001. So here our key number shall be, here we have one significant figure, two significant figures, and again here we have one significant figures. Why one significant figures? Because after 0, after point, though it is point over here, this is the decimal point over here, but here all these are non-zero terms. Therefore, to the left we shall not be including any non-zero term, and to the right of decimal we shall be including. But if there would have been 0.1001, then they would have been included. But since we do not have any sort of certain things, therefore what we can write it as 001, that means only one significant figures. 0 between non-zero terms is always included. So let's just multiply them. On multiplying them, what do we get? We get as 6. Okay, I'll have to change it. Let's make it 1 6. 2 it becomes, 3 it becomes, 2 it becomes, 3 it becomes, and 1 it becomes. Therefore, we are left with the specific term of ours, that means the key number. This is our key number, and according to this key number, the answer should be left like this. So the answer goes like 12 6 7 12, 192 it will give you, and let's place 0 as well. Let's count the point. 1 2 3 4 5 6 7. Like this the answer is coming. But key number says that only one significant figure has to be given. Therefore, we can write it as 1.920 10 to the power minus 6. Still not a one. Is it a one significant figure? No, not yet. So let's just make it one significant figure. We by rounding off. Since it is greater than 5, therefore what we need to do is we will increase this term by 1. Therefore answer becomes 2 into 10 to the power minus 6 in terms of one significant figures. That is our key number. So this is how you will perform multiplication and division. Same goes for division also, and this is how you will perform for multiplication. Now coming on to another case which involves the case of logarithm. Log. How can we perform logs? Logarithm are to be performed. So in order to perform the logs, we need to understand, supposedly we have log 339. Let's take for an example, we have a specific log, say 339, and let's say its value is, let me just calculate its value. Okay, it says 2.530. Whenever we will represent a log like this, it says that its value is 339 2.530. So this part becomes your characteristic, and this whole part becomes your mantissa. So this is how we can perform the logarithm. For log we have this value, and this is whole particular thing that we have. How is log represented? It is usually represented in these terms. Is it like in your before classes 10th, 9th, 8th, you must have read like this is how we represent log. Now what is happening? We have calculated for log 339, which says the value is 2.530. Therefore, while representing your answer or while writing your answer, while why am I writing this? While answering a particular question, your answer should include three significant figures. Why? Because mantissa involves three significant figures. Therefore, your answer should include three significant figures. So, related to this, let me just write a question so that we can perform it. The question is, calculate the pH of solution 4.0 10 to the power minus 3 m of HCl. This is a simple question from a standard book itself. So a question is very clear. Let's just start solving it. We know log H positive will give us pH. Is it? We need to calculate this pH. This pH has to be calculated. Therefore, what we can do is minus log. Instead of H positive, I shall be placing my value 4.0 10 to the power minus 3 and will give me pH. Let's just apply the rule of log, which says that if the log terms are in multiplication, they would be brought into addition. Say log A into B is there. Let's just suppose log A into B is there, so it becomes log A plus log B. Like this the things become. So how can we solve it further? It says that minus log 4.0 minus log 10 to the power minus 3. And for power also, if we have log 10 to the power a, therefore power comes down and becomes log 10. Like this the things become. Therefore, log 4.0 minus 3 will come down, therefore it will become plus 3. Log 10. Log 10 is, we all know it's 1. So it will become minus log 4 will give you value as 0.6010 plus 3, and hence we can calculate the pH. On subtracting this 3 from, on subtracting this 6010 term from 3, we will get 2.40 as an answer in terms of positive terms. Since our statement has only two significant figures, therefore our answer should also have two significant figures. and like this we can solve certain questions related to your log or your anti-log. So this is how you're gonna solve questions or anything related to your significant figures. There are so many questions to come in the series. So in next lecture we shall be discussing about the PYQ. Hope you have understood all about the significant figures. If you still face any difficulty, you can comment me down or you may contact me. Thank you and keep watching.
Transform concepts into success. Expert preparation for GATE and IIT JAM. Master Chemistry with ChemUp Academy. Achieve excellence.